In this lesson, we will go over the graphs of basic functions. To start, we will consider the constant function of the form f of x equal to b, where b here is any constant. Now, the constant function is just a linear function with slope equal to 0. So its graph would look like this for any constant b. Suppose this is b. The y value is b. So any constant function of the form y equal to b or f of x equal to b will have a graph that look like this. The slope here is equal to 0. It is a horizontal line. Now, let's identify all the properties that apply to a constant function. Is this an even function? Remember, an even function is a graph that is symmetric with respect to the y-axis. This is an even function because this line here is the mirror image of this line here. In other words, if you fold the graph along the line, along the y-axis, the two lines here will coincide. So it is an even function. Next, is this function an increasing function? No, it is just a constant function. And is this function here a linear function? Yes, it is a linear function because its graph is just a constant. It's a line. The domain of this function is the set of all real numbers because it is defined on all real number x. What about the range? The range are the y values. For this type of function, the y value is just the constant b. Next basic function is called the identity function. The identity function is a function given by f of x equal to x. This is still a linear function with slope equal to 1 and y-intercept b equal to 0. This function assigns to each number in the domain the exact same number in the range. Now the graph of the function f of x equal to x, or the identity function, will look like this. Now let's identify all the properties that apply here. So again, first it is a linear function. Now is this function odd or even or neither? This function here is an odd function because it is dependent on x. Now it is an odd function if when you replace x here, the equation becomes negative of f of x. So note that if I'm going to replace x, if I'm going to evaluate f at negative x, this is equal to negative x. So that is equal to negative of f of x. So this function here is an odd function. Or you can also say that the point negative x, negative y is on the graph of the function here. Next, is this function an increasing function on the interval negative infinity to infinity? So as you go from left to right, will the function rise? Is the function rising or falling? Is the function increasing or decreasing? From left to right. This function is an increasing function on the set of all real numbers. So on negative infinity to positive infinity. And also the domain of this function is defined on all values of x. So the domain is the set of all real numbers. And the range also is the set of all real numbers. Again, because this function is assigned to each number in the domain the exact same number in the range. So the domain, if the domain is a set of all real numbers, the range is also the set of all real numbers. The next function is called the square function. A square function will have a graph that would look like this. It's a parabola that is facing upward, and the vertex of the parabola is at 0, 0. So this function here assigns to each real number in the domain the square of that number in the range. So again, the square function would look like this. Now, is this function an even function? Yes, you can verify that this is an even function because if you replace x here by negative x, evaluate f at negative x, you have negative x squared, and that is still equal to x squared. So f of negative x is equal to f of x. That makes it an even function. Is this function increasing on negative infinity to positive infinity on all real values of x? The answer is no, because at this part here, it is actually decreasing. And then at the right side of 0, the function is increasing. So the answer is no. Is this a linear function? No, it's not a linear function. Is the domain of this function here the set of all real numbers? Is this function here defined on all real numbers? Yes. The answer is yes. Now, is the domain of this function, is the range of this function the set of all real numbers? The answer is no, because there's no graph below the x-axis, or the negative values of y. There's no graph at the negative values of y. In fact, the range here for this function is from 0 to positive infinity. The next basic function that we need to familiarize ourselves with is the cubic function, or the cube function. The cube function given by f of x equal to x cubed. Now, its graph would look like this. That's the graph of a cubic function. Now, is this function here an even function? That means if you're going to evaluate f at negative x, will you still get f of x? So let's try that. Let's replace x here by negative x. So we have negative x cubed. And that is equal to negative x cubed, which is negative of f of x. So in other words, f of negative x is equal to the negative of f of x. And that means that the function is an odd function. So it is an odd function. Now, is it increasing on all real values of x, or on the interval negative infinity to positive infinity? So from negative infinity to positive infinity, is the graph increasing? Is it continued to rise? The answer is yes. So this graph here is increasing on the interval negative infinity to positive infinity. Is this a linear function? It's not a linear function. It's not a linear function if the exponent of x is no longer equal to 1. Now, what's the domain of this function? The domain of this function here, as you could see, this is defined for all real values of x. So the domain is negative infinity to positive infinity. And since this is continuous everywhere, there's no graph there's no gap. The function, there's an arrowhead here. That means the range of that function is also negative infinity to positive infinity. So domain and range is the set of all real numbers for the cube function y equals x cubed. The next basic function is called the absolute value function, and that is given by the expression here, f of x equal to this symbol here, that's the absolute value of x. Now the graph of an absolute value function will look like this. It will be a V-shaped. So this absolute value function assigns to each real number in the domain the absolute value of that number in the range. Suppose, for instance, if x is equal to -3, it will be assigned to +3 in the range. If x is equal to 3, it will be assigned to 3 in the range. So that's the graph of the absolute value function. Now, is this an even function? It is an even function. One way of looking at it is by, trying to fold the graph along the y-axis and see if the two curves will coincide. Or change the x in your f of x, or try to evaluate f of negative x. F of negative x is the absolute value of negative x, and the absolute value of a negative number is still the absolute value of x, and that is your f of x. So we've seen that f of negative x is equal to f of x. So that makes it an even function. Is it increasing on the interval -infinity to +infinity? No, it is decreasing on the interval -infinity to 0 and increasing from 0 to +infinity. So the answer here is no. That's not a linear function. Now, is the domain of this function here the set of all real numbers? Is it defined on all set of real numbers? The answer is yes. See, there's no holes on the graph. It has graph on the set of all real numbers of x. What about the range? It does not have a y value on the negative values of y. So therefore, the range is not the set of all real numbers. The next basic function is called the square root function. Square root function is given by the expression f of x equal to the square root of x. Now, this function is only defined for all values of x that are greater than or equal to 0. And it assigns to each real number in the domain the square root of that number in the range. Now, is this function an even number and an even function? The answer is no. Is it odd? It's no. Is it increasing on the interval -infinity to +infinity? Well, it does not have a graph from -infinity to 0. So the answer is no. Now, is the function a linear function? It's not a linear function. Is the domain the set of all real numbers? No, the domain is only from 0 to +infinity. What about the range? Is it the set of all real numbers? No, the range for this function is from 0. When you say range, you look at the y value. So it is only from 0 to +infinity as well. Next is the cube root function. The cube root function is given by the expression f of x equal to cube root of x. Now, the cube root function is defined for all real numbers, and then it assigns each number in the domain the cube root of that number in the range. So as you can see here, the domain of this function is the set of all real numbers, and also the range is the set of all real numbers. The function is not linear, it's nonlinear. And is it increasing on this interval? In the interval will the graph continue to rise on the interval from -infinity to +infinity? The answer is yes. So this function here is increasing from -infinity to +infinity. Next, let's identify, is this function odd or even? So you can do that, or you can check that by evaluating f at negative x. So if you evaluate f at negative x, you replace the x here by negative x. So you have cube root of negative x. And the cube root of a negative number, that means you could take out the negative sign. Negative of cube root of x. And that is equal to the negative of f of x. So that means that f of negative x is equal to negative of f of x. So that is an odd function. The next basic function is called the reciprocal function. It is given by the expression f of x equal to 1 over x. Its graph looks like this. Now, as you notice, the graph here does not touch the y-axis nor the x-axis. The x and the y-axis in this case are called the asymptotes of the graph. The y-axis, excuse me, the line x equals 0 is the vertical asymptote, and the x-axis, the line y equals 0, is called the horizontal asymptote. Now, if you look at the graph here, you notice that there is a break in the graph. You notice that there's no graph. Again, this is the asymptote. The line x equals 0 is the asymptote. That means the graph will not intersect here. And in fact, if x is equal to 0, your function is undefined. So that means the domain of this function is the set of all x such that x is not equal to 0. Now its range, the range is the y values. The range of the function here, as you notice, will not cross your x-axis. So there's no value of x that will make your y equal to 0. So the range also is that y not equal to 0. This function here is not increasing all throughout the interval, negative infinity to positive infinity. It's also not a linear function. Now, is this odd or even? Is this an odd or an even function? So to check whether it's odd or even function, you evaluate f at negative x. So evaluate f at negative x. So you have 1 over negative x if you replace x here by negative x. And that is the same as negative of f of x. So this means that this function here is an odd function.